So today I want to talk about Timescale and what I'm going to refer to as the once and future database platform, Postgres. But because we're here in New York City and many of us are New York companies, I thought I'd start with an analogy. New York, as you know, was born as a center of shipping and trade. From tall ships to steamships, its ports connected a growing nation. New York didn't stop there, of course. It kept reinventing itself. Fast forward to the 50s, and Madison Ave became famous for messaging and marketing. It became the content engine that convinced the world to buy stuff. And of course, the reinvention continued. The power of Wall Street and the New York Stock Exchange went global, and New York joined or even surpassed London as the center of international finance. And in the 80s, greed was deemed good. Now, once again, New York has reinvented itself as a tech hub. In fact, from 2015 to 2022, New York grew from 11 to 144 unicorns. Many are in data, and many are thanks to amazing investors like FIRSTMARK. They bribed me. The point is that New York is not a niche city known for only one thing. It is the ultimate platform city built for the everyday person, and this diversification has actually been its power. Throughout its history, it's gone from strength to strength. It remains a center of global commerce, global marketing, global finance, and now global tech as well. And I think there's a reason they say, if you can make it here, you can make it anywhere. So why am I talking about this? And let me try to bring the analogy home, however strange it might seem. And I want to talk about databases and data infrastructure. And hopefully you'll see the connection to reinventing yourself on firm foundations. Even though it has its roots back in the 1980s, Postgres is now one of the most popular databases for developers. And it's not a niche database, good for only one thing, but a full database platform. And we'll see why in a minute. But first, a bit about Timescale. Timescale launched our database in 2017, building on Postgres. Since then, we have raised $180 million in funding, becoming one of those New York unicorns, with support from Benchmark, NEA, Redpoint, Tiger Global, and others. We offer both open source software with hundreds of thousands of teams using Timescale DB, and primarily build our commercial business on our managed Timescale cloud with more than 1,000 customers. We've seen amazing growth the last few years, from digitally native startups to the largest public enterprises. Today, these companies trust Timescale to build their powerful applications with Postgres. But how did we start? So let's go back to 2015, when there was a lot of excitement about the Internet of Things. So the question was at the time, do these new IoT workloads require new data infrastructure? In fact, we started Timescale not as a database company, but trying to solve this IoT data problem. We started by looking first for a good time series database that would fit our needs. Fast, scalable, spoke SQL, and could combine sensor and business data. Unfortunately, we couldn't find it. So we realized we had to build it ourselves, the proverbial scratch your own itch. Now, one might have been tempted to start anew and build a niche database focused on IoT and time series data. And in fact, that's the approach taken by the vast majority of existing time series databases. But we said no, and instead we extended Postgres for time series and real-time analytics. This allowed us to build for the everyday developer who doesn't want a brand new tech stack for every new workload. Now, what do I mean by extend? We didn't fork Postgres, but rather hooked into its extension framework. And this allowed us to write low-level code in C and now in Rust that has hooks basically throughout the Postgres codebase, changing its query planning, query execution, new storage engine and storage layout, and so forth. And that's what we did, and probably have taken Postgres extensions further than any development team. But the real win, as Postgres gets better, so does Timescale DB. And as Timescale gets better, more developers continue to grow with Postgres. And in that regard, it's a virtuous cycle. So how do we improve Postgres to work with time series and real-time analytics? Generally, a number of improvements to increase scale and performance. So-called hypertables, which automatically partition data to improve query performance and support high insert rates. Hyperstore, which is our hybrid row columnar engine, accelerates queries on these hypertables while reducing costs via native columnar compression. Continuous aggregates give instant results, and incremental materialized views that you don't need to worry about. Tiered storage transparently tiers huge tables on both high-performance disk and bottomless S3 object storage, hyperfunctions, a lot of hyper, simplify and accelerate analysis with SQL, such as fancy approximations or gap-filling algorithms. And then, of course, combine this with a modern developer experience. So still 100% Postgres with that whole ecosystem, now with a cloud-native architecture that separates compute and storage, allows them to scale independently, separates compute and compute horizontally to independently scale read and write reads, and then modern serverless ops experience, database forking, point-in-time recovery, high availability, replication, auto upgrades, and more. And in fact, earlier this year, we actually, a recent acquisition through Popsicle, which is an AI-enabled SQL editor and dashboards. But my broader point, obviously there's a lot of engineering and product development over the last number of years. By innovating on Postgres, not only do we inherit all of Postgres's reliability and familiarity, but we can make it basically faster and more cost-effective as well. In fact, not only is Timescale a better database for time series than vanilla Postgres, including compared to both Amazon's RDS and Aurora, but it is also better than custom-built proprietary time series databases like InfluxDB and AWS TimeStream, even with their NoSQL limitations. So that was job number one, basically make Postgres the best place for time series and real-time analytics. But now it's 2023 with the rise of generative AI. And so the same question arises, does a new data workload require new data infrastructure? After all, Gen AI models are built often on vector data, and large-scale vector workloads are common in AI applications like RAG, search, and AI agents. So do these new vector workloads require new databases? And many said yes. In fact, a number of niche vector databases were launched, and much VC dollars were deployed into these new companies. But we again said no. And the idea is that while the last 10 years in AI was about model training and model building, Gen AI today is finally about inferences and applications in production. And this is where real mature database platforms shine with their deep flexibility and operational capabilities. And again, we want to build more for the everyday developer who doesn't want to learn a completely new stack for another new workload. And so our solution was the same as we did before. You can see where this is going. We extended Postgres in order to help now developers build powerful AI applications. And much like time series, we focused on performance and ease of use. So to extend Postgres for building AI applications, this June we open sourced two new extensions, PG Vector Scale and PG AI. The first, PG Vector Scale, is about vector search. It builds on the open source PG Vector Postgres extension, but supercharges it using advanced indexing and compression techniques. For example, streaming disk ANN scales fast vector similarity search to billions of vectors, and what we call statistical binary quantization reduces the storage with improved recall or better accuracy. But because it's in a database, you could continue to do rich filtering in SQL on your metadata, on time, on geospatial information, or based on tenant permissions, all which is normally very difficult in vector space. And you could join basically that query time for things like citations or cross-references to build confidence in your answers. The details don't matter. Well, they do. You can look more into them. But the high-level message is it makes Postgres fast for vector data. Now, you might ask, oh, that's just vector scale. And of course, I said that the second part, PGAI, is about better developer experience. And this actually allows you inside your database to call into AI models like OpenAI, Anthropic, Cohere, or open source, even self-hosted models with Ollama from directly within Postgres, and then making it easy to build basically end-to-end pipeline for things like text generation, creating vector embeddings, chat completion, all directly in your database. This allows data pipelines to become much easier. Once a new piece of data, for example, is inserted into your database, PGAI can automatically create searchable vector embeddings of it, and subsequent RAG queries to it will immediately use it. This is almost like a zero ETL. You don't need complex data pipelines or worrying about data synchronization or freshness. So I claimed fast and easy, so I thought I'd share a few numbers and then go into a demo. Compared to one of the leading vector-only databases, Pinecone, PG Vector Scale is 28 times faster for high recall scenario. High recall means you actually care about getting the best answer. These results, for example, are from industry benchmarks with 50 million embeddings. So this isn't a toy example. And we see these results in practice. We have customers certainly running in production with hundreds of millions of embeddings. Furthermore, this performance boost comes even at significant cost savings. The monthly costs of running such a PG vector scale deployment on AWS is 75% less expensive than Pinecone. Now, those familiar with Pinecones might say, isn't there a version that runs at lower recall but is higher performant? Yes. And their PG vector scale was still 40% faster queries and 50% higher throughput. And the idea is that something like a vector-only database like Pinecone had you choose between these two high 90% and 99% recall, while PG vector scale allows a much smoother continuum. But that's about raw performance. I thought I'd show a little demo of the developer experience using PGAI. Let me see if this will work. This is PGAI running in Postgres. The UI here is also Timescale's Popsicle, spelled Popsicle, which is both a desktop and cloud app.
Let's take a look at some of the developer experience enhancements that we made in the PGAI extension. So I'm here on my favorite Postgres administration tool. It's called Popsicle. I've connected to my Postgres database hosted on Timescale. And what I have in front of me is a table of quotes about different US cities made by famous people throughout history. So we have quotes from Truman Capote about New York, Mark Twain about Boston, these sorts of things. And one cool thing about Postgres and pgvector is that you can store embeddings alongside your relational data and even your time series data in the same system. But you may notice that there's one problem with my table and that there's no embeddings created for the quotes that I have. So let's fix this using the PGAI extension to create some embeddings. And how we do this is we use the built-in functions for embedding creation. It supports creating embeddings from OpenAI, from Cohere, and open source models from Ollama. In this example, I'm using the OpenAI text embedding 3 small model. And now that that's run, that should have created quotes for, that should have created embeddings rather for the entire table. So let's run the query and see if the embeddings did get created. And there you have it. You can see that we have embeddings created for all of the quotes in the table that weren't there before. This was just possible in one line of SQL, and that saves you a lot of time instead of having like an external data pipeline, etc. So let's take it up a notch and let's do something more useful with the embeddings. In this case, a retrieval augmented generation or RAG example. And in this case, what I'm going to do is do some reasoning over the quotes that I have. So in this case, what I want to do is I want to know from the quotes in my database, what do people say about these different cities? So I'm going to run it for New York, San Francisco, and Chicago. And I'm going to be using this generate RAG response function, which I've made using PGAI and which we're going to explore in the moment. So while that's run, it's going to take a couple of seconds to chat with OpenAI API. Let's take a look at this function. So it's generate RAG responses. It takes in a query text. And what we're doing is we're performing a similarity search using pgvector to find the most similar quotes to a given string. So in this case, if I ask about New York, it'll find quotes similar to New York using semantic search. And then what it's going to do is make an API call to GPT-4o Mini in order to summarize that. And you can take a look and customize things like the system prompt and the objects passed along. So, and then finally, it returns a response. So this is the kind of thing that you can do completely in SQL. You can do RAG just with PGAI. And now that that's done, let's take a look at the results from that table, the summaries table. And there you have it. You can see that we have, for each question that we asked, a summary generated. And let's take a look at one of these summaries. And you can see here, for example, this is for New York City, what people like Truman Capote, Ayn Rand have said. And this is a really cool use case showcasing LLM reasoning on data, all without leaving your database. But while I've used this, really nice looking Postgres administration tool, let's peek under the hood a little bit. All of this is just happening inside the database. So I'm going to connect to the same database, this time using my terminal, using pSQL, and I'm going to run a RAG function for what do people say about New York City. And we're going to verify that, hey, I'm actually getting a very similar response. Once again, this is peeking behind the curtain and recognizing that this is all happening at the database layer. You can see, hey, here's the response that I'm getting, and I can do whatever I want with this. So that's it for the demo for PGAI. Hope you've enjoyed it, and thank you so much for listening.
Hopefully beyond this numbers, it shows a little of the developer experience. No additional services, APIs, or pipelines. And hopefully if there's one thing you take away from this talk, a new data workload does not require new database architecture. You might think of Postgres as an OLTP database, but we first proved that it could be powerful for time series and analytics. And right now we're showing it could power AI and vectors as well, all without a new architecture. And to bring it full circle, similar to New York, which constantly reinvented itself on a firm foundation, Postgres, we believe, is that similar platform for building powerful data applications, and Timescale has supercharged it for new use cases. First for time series analytics, and now for vectors and AI. This allows our goal for everyday developer to build powerful applications with just Postgres. Thank you.
You guys were kind of early to the whole wave of building great database companies on top of Postgres. Is that fair or no?
I think we were possibly the first company to really do an extension. I mean, Postgres has been a platform for a while, but in the past, most people have forked the database. Pivotal to this Greenplum, Amazon Redshift is actually a fork of Postgres 8. They dead end then. And the problem is they diverge from the community, which is one of the largest companies out there, or one of the largest data platforms out there. I think the other thing is that we knew from the beginning that we were also building a managed cloud platform. And so people in the past would think of extensions as like tiny little plugins, operational things, when really we're probably one of the first to think of it as taking it into new places where it hasn't been before.
And some questions as earlier on the company. So you're a Series C company. Any stats you can share? Number of people, customers?
Sure, we're about 150 people globally. We run. I mean, the fun thing about running a managed cloud is we, run global support. To follow the sun, weekend, full everything, because we have customers who run 24/7. More than 1,000 customers. Open source is hundreds of thousands of people using the open source, and kind of continue to grow really, really fast over the last couple of years.
Thanks for the presentation. Any specific reason for choosing Postgres? Like there were other servers or other databases which are OLTP, just Postgres specifically. Any specific reason for that?
I mean, I think two things. One is when we were, like I said, we actually started looking to build an IoT data platform. We initially were not looking to become a database company. And that was a real story at the beginning of, we looked at this, we were using existing open source things, and we're really unhappy with it. And so we first built this internally. And we did it because we thought it was a really powerful platform. And it had the right type of hooks that allowed you to do the kind of customization that we wanted. Probably the only other big open source database out there is MySQL, and had a very different type of hooks. And of course, it was Oracle at the time. I think one of the reasons why the trend of Postgres rising so much is actually because of that acquisition. And so it really seemed like a no-brainer to build on Postgres.
Hi, thank you for your work. We use PG Vector, it's really amazing, and these extensions will make it even better. I wanted to ask you, so the philosophy of shifting the queries from your application to the database layer. Basically, I open connection with the database. Now, it takes time for database to get a response. So basically, all this time, this connection is hanging. So now thousands of users are sending the requests at the same time. So now my database is pretty much becoming not responsive because in the backend, it connects to all this, it sends all these queries and it waits and waits and waits. So how do you scale that?
So I think two things that you're mentioning. I think there's two sides to this, like you described. There's the vector, the RAG approach, the vector search approach, and the RAG. I think what you're talking about is I showed two things. One is how to do fast vector similarity search. This does not have any external connections, as you point out. The second part, which we did, was the one where you could actually call out to different APIs. To be honest, I think the whole industry is still figuring out what the right architecture is there. In fact, if you look at most people learning the production, they're still not at this. I mean, we serve global customers that normally are doing hundreds of thousands of requests per second. Nobody is taking RAG apps to that scale today. There's a lot of normal stuff that you do. You do a lot of connection pooling. You actually have scale it horizontally through replicas. So there's various things you could do to accelerate this. But I think this problem is not different if you were deploying these as microservices. When the latency of an existing OpenAI lookup takes 5 seconds, you're going to be doing a lot of queuing in the thing. I think we're still figuring exactly what the right architecture are and how that brings it really down. The other nice part about this is because this allows you to support any model, including things like Olama, where you could chat locally. You could also tune these for different size models. You can tune them for internal applications. And I think we're going to see a lot more of that type of thing as well.
Hey, so cool. So you mentioned IoT and sort of the start of it. And I guess now the generation is the IoT has like embeddings. And so would you be able to store like the image data and the embeddings? And like as time series for finance, you can have all these aggregation functions over time. Will you kind of have the ability to look at like the embeddings over time and sort of moving averages, things like that?
Yeah, so one of the really interesting things about, I shared you 2 different workloads, vector embeddings and time series. And one of the interesting things is because it's all in the same data structures in the same database, there's actually ways that combining them does benefit. For example, one thing that you might do is we have some customers who are doing certain applications where they're doing images. They're not storing the raw image in the database, but they take an embedding on the image, they store that in the database. And they want to reason over time. They want to reason what happened in the last 24 hours versus the last week or whatever. It turns out that's vector search over time is really bad. You can't reason about it. And so much like we have a notion of time with the way we do time-based partitioning for all of our time series, you could actually store those embeddings in the same way. And you could do things like you search and similarity search for images, but then the time query becomes a normal SQL predicate, so you could actually do correctness there as opposed to just approximation. So all these things combine actually really well.
Thank you for the great extensions. So we have evaluated PG vector scale, okay, when July or August time, and the performance was pretty good, and yeah, it was marvelous. But the problem what we had faced is RDS doesn't support that extension at that particular time, okay? So the same thing will happen in future also. So you will create some kind of great extension, but the cloud provider won't support that extension until that particular time period, okay? So do you have any particular...
come to our cloud.
so that's actually, so we are more in the healthcare, so we have our own limitations to do that. And do you have any way to mitigate this kind of issue? It's not like a technical issue, it's more like adaptation issue.
Sure, so 2 things. One is, I mean, we think a lot about open source licensing. I could talk a lot at this. Timescale DB itself is free for the community to use, but the cloud vendors cannot offer it. That is by design, because we are happy for people to self-manage it, but obviously if people want to go to managed service, we want them to come to our cloud rather than AWS RDS. PG vector scale, we actually did release under the Postgres license, so the cloud vendors can host it if they want, and we've already been talking to them. Yeah, it takes them some time to move things, but once they host them, they're generally pretty stable at doing so. But you know, we also serve a lot of healthcare companies, so happy to talk to you later. And Germans too, in Germany. We have regions all over the world. That's why you run global ops.
So you may have just partially answered the question with the license around RDS, but I'm curious, what's been the most impactful thing you guys have done to differentiate your cloud offering from the open source?
I mean, I think, so the interesting thing, I mean, we have that architecture I described above. So our open source itself has all of the core of the extension. There's nothing in our cloud in the extension itself that is not community. If you are, as a development team, want to use a managed service, come to us. If you want to self-manage, you could do it yourself. I think on top of that, our cloud has an architecture that, I talked a little bit about that, separates compute and storage more natively, builds bottomless transparent tiering to S3. There's a lot of stuff that's really, we're taking Postgres in a cloud native approach. For example, I showed you what looks like a hypertable. You query it, it looks like a table. Part of that table is row-based format, part of that is hybrid columnar format, part of that is backed by Parquet files in S3. So we have what looks like a single, we actually built an insights product that all of our customers see as part of when they log in. That insights product is actually backed by a Timescale service, much the same as any of our customer could do, that has more than a petabyte of data and currently is ingesting, I think last week I saw 800 billion records a day. So you don't normally think of ingesting 800 billion records a day in your Postgres database, but that's how we could scale it. So some of that stuff is not going to work very well in self-managed.
Mike, thank you so much.
Thank you.
So much.